We're joined today as well by Jamie Mitchell from Veeam and John Shedlovsky from Tintri, who are going to be presenting the two technologies and will also be around for Q&A with Rob at the end. So with that, I'd like to turn it over quickly to Jamie Mitchell at Veeam to discuss and give a brief overview of the Veeam technology.
Hey, good morning, everyone. As Mark mentioned, my name is Jamie Mitchell. I'm a systems engineer here with Veeam Software, and I want to give you a high-level overview of Veeam for those that might be unfamiliar with the product. So what is Veeam? Well, Veeam is a modern data protection tool that is built just for virtualization, and it delivers powerful, easy-to-use, and affordable data protection for both VMware and Hyper-V. And make no mistake, Veeam is a fundamentally different tool from traditional legacy-based backup programs. So let's talk briefly about some of the high-level differentiators that make Veeam unique. So let's start with our agentless approach. So agents are bad in a virtual environment. They don't make sense, right? They made sense in a physical environment. Each machine had their own dedicated CPU, memory, and storage resources. But in a virtual environment, you might have 10 different VMs running on one set of underlying hardware. So if you have agents present on all those VMs, they're in constant resource contention. So Veeam realizes that VMs are just simply images present on the disk, meaning an agent-based approach is just unnecessary and cumbersome. Not only that, the flexibility of a virtual environment is completely juxtaposed to the rigidity of an agent-based approach. So with agent-based approach, of course, you have to deploy, manage, and probably license each of those agents, creating a management nightmare. And of course, if Veeam is offline and you're relying on an agent-based solution, well, it's not going to get backed up. So traditionally, image-based backup tools have come up short in the granularity of recovery, but with Veeam, we're still able to provide recoveries at the file level, the application level, such as Exchange emails, SQL tables, AD users, etc. And of course, we have the capability to recover an entire VM, and that takes place in a matter of minutes using vPower technology, which we'll talk about in just a minute here. So let's touch on our current operating system and hypervisor support. So we're up to date on compatibility. We support vSphere 5.1, Hyper-V 2012, 2012 also as a guest operating system. And that includes VHDX and VMs on SMB 3.0 for Hyper-V 2012. And while we support change block tracking with VMware for a lengthy amount of time now, and that basically provides us with really rapid incremental runs, right? We've implemented our own version of change block tracking for Hyper-V, which includes support for cluster shared volumes. So finally, let's do a real brief recap on our virtualization-powered approach. So this is an image-based backup and recovery tool, and it provides both backup, which would be sending an image, a compressed and deduped image to disk, as well as replication, meaning you can do host-to-host transfer of an entire virtual machine. So we pioneered such technologies as vPower, and as we mentioned earlier, it gives you the capability to start up a VM directly out of the backup file, sitting on the backup storage, without moving it or decompressing it, right? So this same feature set allows you to recover an entire VM into a fenced-off isolated network called a virtual lab, and we utilize that instead of pushing it in production, pushing it to this fenced-off network to do recovery verification or recoverability verification called SureBackup, testing your backups, as well as empower our sandbox and application recovery platform. And in both the spinning it up into production, which we call instant VM recovery, but also with the virtual lab approach, using it as a sandbox or a test bed, that VM starts in literally 3 to 5 minutes, and it's up and running. So great feature set, built for virtualization. Like I said, agentless approach still provides you with the granularity that you need to do your day-to-day recovery. So with that, let me go ahead and pass it back over to Mark.
Thanks, Jamie. Appreciate it. And I'll just quickly turn it over to John Shedlovsky from Tintri to go through the Tintri technology.
Great. Thank you. So I'm John Shedlovsky, a systems engineer here with Tintri. And if you haven't heard about Tintri before, Tintri is storage. It is hardware. It is, actual gigabytes and terabytes of capacity. But what makes Tintri unique across all the, really the rest of the industry, be it the legacy storage folks or the emerging, maybe flash optimized folks, is that it is a new class of storage. as differentiated as direct attach is to SAN and SAN is to NAS. Well, this VM-aware storage is a fundamentally new class of storage. And the key thing there is that the fundamental organizational unit, the thing that you manage, the thing that you do snapshots and replication, the thing that you do a troubleshooting and quality of service type work on, is not a LUN, it's not a volume like you might in a legacy storage device, but it's a VM. It's a VMDK, it's a VDIS. And while being incredibly simple and actually purpose-built, it's only for virtual environments, it allows administrators, storage administrators, virtualization administrators to really be on the same page as the application owner. Whether that's a SQL or Oracle database or an Exchange instance or a desktop. Now everyone's on the same page around what's going right and what's going wrong on the particular array. So next slide. So what is it? So each Tintri node is a data store. It's a massive, massive data store. If we take our 540 as an example, it's a 12.25 usable binary terabyte data store presented over IP, so over MFS, so over 1 or ideally 10 gigabit Ethernet to the ESX hosts. But it's a massive, massive data stores. And like I said, it's incredibly simple. It's already pre-tuned, pre-optimized for virtual workloads. So there's really nothing to do after you mount the data store. The only way we could get away with that, the only way we could really get away and actually excel at having hundreds of server VMs or up to 1,000 desktop VMs or a combination of all those on one single data store is if, like I said before, if we're VM aware, if the system fundamentally knows that this I/O in or out of the system is associated with a particular VM. And giving the administrators all that visibility and all those tools to troubleshoot and optimize based on that. And take care of their storage tasks, like I said, snapshotting, replication, cloning, all on that per VM basis. And the last bit, we know that virtual environments are going to be very performance intensive. Now being able to deliver 60, 70, 75,000 I/O at sub-millisecond type of latencies. So next slide. So what is VM-aware? And I've touched on this a little bit, but it's really everything that the system does centers around the VM. So all the statistics, all the features, the quality of service, but also equally important with quality of service is performance isolation of individual VMs, making sure that VMs don't impact one another, making sure that you don't overload the system, not just capacity, but performance as well. And in the end, it's really the ability for the storage admin to be on the same page as the server admin, as the application owner, so that everyone's seeing and discussing the problem with the same information, with the same sort of perspective. And hopefully this will come to light in Rob's discussion in a more meaningful way. But that's about it from a rough introduction. And Mark?
Thanks, John. Appreciate it. And hopefully that was helpful for you folks on the webinar in terms of the architecture. At this point, I'd just like to turn it over to Rob Girard. We'd like to thank you, Rob, for joining us and look forward to your presentation. So I'm going to hand over control to you and let you go ahead and take over.
All right. Thank you, Mark. And thank you to Veeam and Tintri for having me on today. So hopefully you can see this now.
Yep.
Okay, so just a little about myself. I'm a bit of a virtualization nut, and that's mostly because I'm a generalist when it comes to IT. So have over 15 years of professional IT experience. That's in the trenches stuff. Been through quite a bit in that time frame. And all of that is kind of brought me to where I'm at today, and working with new technologies and using them to make my life easier and life easier for those around me and users, etc. So I stumbled onto VMware back in 2005, got certified then, and been drinking the Kool-Aid ever since. My background is primarily Wintel. Started out MCSE, some CCNA, and some PIC stuff, and some early CNA stuff in there. And so just a big mix of stuff brings us to today. So work with MaplesFS. I joined about 2 years ago. MaplesFS is a global financial firm. We're an independent provider of specialized fiduciary and fund services. We're headquartered in Cayman, which is our bulk of users, and we've got users around the globe in we've got Cayman, Dublin, Dubai, Hong Kong, London, Luxembourg, Montreal, New York, Delaware offices. I myself am in Montreal, and there's a bit of an IT presence here, primarily development, and there's a couple guys that work with me on the infrastructure team. MaplesFS is approximately 250 people, a little bit over, and growing rapidly at about 15% year over year. We fit into a larger set that's around 1,000 people when we look at our parent company, Maples and Calder. And so internally, there's some blurred lines of which gear is maintained by a global infrastructure group and which is specific to MaplesFS. And so more and more is unique to MaplesFS, and we've sort of carved out a chunk that we can call our own, so that we had a little more flexibility to drive on with some initiatives and break away from the mold where it makes sense, yet still take advantage of some global IT services across the board. Our applications are internal and client-facing apps. So internal might be systems for doing some fund accounting, or it might be Outlook and Exchange and internal SQL and that kind of stuff. Intranets. And client-facing is we've got a portal for investors to log into to check get some reports on their share status and whatnot. We've also got some risk management dashboards for some investors to get in to take their complex portfolios and distill it down as nice, pretty graphs and stuff. So in terms of what we have, it is primarily Wintel, but there are a number of Linux VMs, mostly virtual appliances and stuff. They're custom built. And we've got a broad range of Citrix, Office, Oracle, SQL, Exchange, SharePoint, IIS, FileSite, and IDLE, which are autonomy technologies for document management. And all of this is sitting on VMware. We are 100% virtualized now. So if I drive into servers, what we had before, now this is just production, but we had around 40 servers, so that's 2 C-class enclosures. Half of those were virtualization hosts with an average 7-to-1 consolidation ratio. A couple of sockets each, 32 gigs of RAM was the average. Virtual connects were 1 gig fiber channel to some HP EVA storage. The storage was shared between both groups and would be a point of contention because there would be hiccups that would happen, latency spikes, and there was a lot of finger pointing on who did it. Was it this group, that group? And then even if it was us, but it was very difficult to find out where the bumps were coming from. And so I wanted to change that. And so what started as a storage initiative took on something larger. I wanted to get everything into VMware Enterprise Plus and be running the latest and greatest. But like everybody else, there's a budget to maintain. So I started reworking that original budget, and as I started to step back, I looked at the entire thing and just did it differently. So poor visibility was a major thing. Availability, lack of management around it, capacity constraints. We were constantly hitting alarms, thresholds. We had a lot of hardware, but it wasn't necessarily efficiently used. And for storage, we had over 20 terabytes, and we were hitting the ceiling on that. And I thought, so well, if I'm going to replace this 20 terabytes, how much do I need? And I thought, well, I probably don't even need 20 terabytes, and that's including a headroom for growth. So my thinking on that was a lot of it was thick disks, a lot of it was done different ways, and I thought, well, if the storage was a little smarter, maybe I could fit into a smaller footprint, and then take that whole budget and rework some things. So what I ended up doing was consolidating that down to 3 servers. So we've got an average of 45-to-1 consolidation ratio. Actually, it's a little closer to 50 now. That is maintaining HA admission control to keep an N+1 redundancy. Everything is now Enterprise Plus, so that's 6 sockets to license for the VMware, the Windows Data Center licenses, Veeam Enterprise licenses. Go down through the build that I have are 2 sockets, 16-core AMD processors at 2.6 gigahertz pop, 192 gigs of RAM, which seemed like a good number for running approximately 128 gigs of physical VMs, which would work out to about 192, taking in the N+1 redundancy of it. It's got 4 10-gig NICs on these Brocade 1860 adapters. When I was looking at the blades, I noticed that there were a lot of cool cards that were available on rack mount that weren't necessarily available on blades. So I started to rethink all that, and I thought, well, if I'm going to put in new hosts and stuff and maintain these enclosures, I would need to upgrade the virtual connects to put in some Flex Fabric or at least Flex 10 to get my 10-gig connectivity. And that 10-gig connectivity still wouldn't be core switches. And I just started looking at this thinking, yeah, it's not going to happen. And I just kept reworking things. And when my footprint became a lot smaller and all the numbers were suggesting that it could be done, I started to look at it quite a bit different. The storage I ended up going with was Tintri VM store, which gives me 12 TB, so usable terabytes of storage, as it would be shown to you in vCenter. And there's no LUNs to cut up. Plug it in, give it an IP, hit the management, and it's really simple. You just point it to however many vCenter servers you have, and it starts to do the magic for you. It really tunes itself and just runs. Nimble was a big one that I was looking at as well, and I wasn't sure with both companies being startups, so I ended up getting both, and just to be on the safe side, one is for VMware only, the other one gave me that flexibility in case there were some other needs, and also would be a great spot to hold my Veeam store. So because there is some hybrid cache flash in both of them, they work quite differently. With a little more horsepower under the Veeam store, I can do a lot of the cool things like virtual labs, SureBackups, and run these VMs usable as opposed to, so I have 3 VMs running out of my backup store, but they're so slow that they're not usable. This is, functional VMs. In the event that something happened to the primary array, I also wanted to be able to bring VMs up as in an instant recovery, fairly quick as a primary response, and then beyond that, fail over to our other data center for DR. But I'd rather keep it all on site in the first case when possible, and so this seemed like a good solution to do that. Backup and DR went with Veeam, backup and replication, enterprise. Additional enhancements, I brought in VCOPS, vCenter Operations Management Suite, so I have some nice visibility over everything. It complements really well with the amount of visibility I get with Tintri into the storage. There's some insight that I can get from one and not from the other, and vice versa. Greatly reduced cost of ownership, and the design is very scalable and flexible. So at DR, I'll just blow over this pretty quick. Basically, we had very similar setup of production in our DR environment. Lots of physical servers, some VMware hosts. I replaced that with 2 servers instead of the 3. So I wasn't concerned with doing the N+1 in a DR method, or when we're in DR mode. And so the whole workload should be able to run on N-1. So 2 it is, and so that works well with the replicas sitting there. So they're just from Veeam. They're sitting there. They're turned off. They're constantly replicating, which is really nice because I don't have additional. I don't have additional VMs that are kicking around that aren't my DR copies that show up in AD, that show up in antivirus, that need patching, that need this, need that, have their own security footprint that needs to be protected. And it's nice to just have these off, but I know that when I bring them up, they are what prod was, minutes ago or hours ago, depending on the settings I have for the various tiers. So let's dig into actually seeing the app. And Mark or someone, can somebody just let me know that you're still online and I haven't lost you?
Absolutely, we're still here, Rob.
Cool. Okay. So let's. So I've got an issue here where some departmental data had gone missing from a complex multi-tiered application. You know, we don't know when it was missing, but when you ask the user, like, it was there Friday. Oh, I'm sure it was. I use this all the time. Now, this application in question is one called FileSite, and if you're a legal firm, you might be familiar with it. So let me just jump over here. And I'll jump into vCenter. And so FileSite is comprised of 13 VMs, so it is relatively complex. Of that, 7 of those are strictly for indexing. And so that leaves us with 6 VMs. So we've got a communications component, a SQL tier, we've got some middle tiers, and we've got storage. The whole thing, the storage is around 4 terabytes between 2 systems. We've got 60 gigs of just the SQL data, and the whole VM is up around 300 gigs. And add in the other servers and stuff, we're sitting at around 4.5 terabytes for this application before we get into the index servers. Index servers are about another 900 gigs of just raw index data. So this is a strange one because it's document management. So behind the scenes, we've got files that are held, and they're just numbers. So like 1256789.1, and all of those are linked to something that looks like folders to the user through the SQL table. So if somebody deletes it, the data is still there, but those folder structure in that is deleted from SQL. So it's rather complex to restore. And there's a big process to do it. So to go and try and restore to that Friday just to find out that maybe that data is not there would be a real pain. And so then, okay, well, let's just be safer and let's go Thursday. And it turned out that no, the data still wasn't there on Thursday. And to rebuild this environment, or even enough pieces just to check in an easy way, you know, would take me, you know, over a day, maybe longer, and that's because I don't necessarily know that application really well. But I've got these VMs sitting here, and I know how to work with VMs really well. So what I can do in Veeam is take advantage of the SureBackup, and let me just pull that up for you here. So in Veeam, SureBackup is a way to put together some VMs that all belong together. So here's our SQL server, our couple middle tier servers, our communication server, and our domain controller. So when we fire this up in a virtual lab, all of these will come up. They'll all run directly out of the backup store. So I told you this is about 4.5 terabytes. I mean, to wait for 4.5 terabytes to be recovered, assuming you even have the space to put that to recover, may not be realistic. And in the event that the data went missing sooner than you thought, it's going to take that much longer. So in this case, and this is one from about a week ago that had happened, I go to the Sure job, and let's see here, and all I would need to do in my backup is jump onto it, and I would say start to, and I would pick a point in time here, and this is anything before. Now this job might be comprised of multiple, all the VMs in it are from multiple backup jobs, so I don't need to worry about getting them up together. They're going to come up into an isolated network, and I can then use my primary client, hit it from the production network, even though it's isolated, with a Veeam. They call it a virtual lab. It's a reverse proxy router that makes it pretty slick to get from one network to another without worrying about data in that isolated network from creeping out. I can then point to an alternate IP that maps to it, hit it, and it functions like normal. From there, using the normal client, I can check, or I can hand it back over to the user and say, hey, is your data there? Yep. And when it is, they can drag that out to another, into the real session, and have them both in one view. So it's huge improvement in this use case, but there's a lot of ways that you could use this. So I had started one up here just this morning, and again, it was just start 2, and I chose a date. And I look, and this one's a little smaller. It's got 4 VMs in it. And when I jump over to take a look at that one, we'll just change our view a bit here and go down. I've got the 4 VMs sitting here. They have the same name as production, but they've got this serial number at the end of it. And what's interesting is if I look at one of these VMs, the storage that it actually sits on is this one called Veeam Backup, and then the name of my backup server. And this backup store is an NFS mount that is actually mounted from that Veeam store, which is a VM itself. It's presented out of there to the hosts, and if I were to look at the data store, all it's got are the 4 VMs that I just recovered. And so I didn't have to wait for these to come up. They're still living inside the backup store. It's nice and quick. Anything that happens in there, if I want to throw some patches at things, test this, test that, it stays in there, and when I decommission it, it's gone. If I want to bring these out into the real world, I can do that too. And on them, their network is off, it's isolated, and it all goes through this reverse proxy. So this was a cool case where, without much admin effort, a few minutes of right-click open to, I could get a fully functional environment with all the VMs that I needed for it to be functional. And it doesn't happen quick. I mean, it's close to an hour in this case to bring it up. But when it is up, it's a fully isolated environment, 4.5 terabytes of data, fully configured, ready to go, and usable. How are we doing for time, Mark?
I think we're doing well. We have plenty of time.
Excellent. Okay. Now, so the next one is another example of one of these technologies. In this case, I'll focus more on Tintri. And I just said moron. Sorry about that. Okay, so Tintri VMware storage gives me lots of insight. Now, this thing's been running awesome. We've got over 130 VMs on the Tintri store in production. They run smooth. It's nice. There's no latency to worry about, and you know, it's funny because I want to showcase the time that we did have latency and we melted this box down. And it's like, well, you know, I'm not sure if Tintri would choose this example of, hey, yeah, why don't you just talk about a time where our box somewhat melted down? I said, no, this is fantastic because this was very common in the other environment. But this time, so we run global, and I'm not awake 24/7. I'm awake a lot. I'm on the systems a lot, but not all the time. So when Hong Kong is online or Dublin comes online, they're getting a 5-hour head start on me. So there was this maintenance job that was configured wrong to do all this re-indexing, do some deduplication of it, and a compact of this data. And there's about 900 gigs stored across 5 separate VMs that are all different content index engines. And when all of them at once just started to pound on it, you know, the cumulative effect was pretty bad. So there was latency. Now the guys that were responded to it are not super familiar with Tintri, but they know how to get into the web interface. And within a couple minutes, it was super clear to them what had caused the issue, so they could jump in and power those VMs off, or you know, take whatever actions might be necessary. So that was done. Performance resumed to normal, and we quickly find out what had caused it. Now, you know, I'm not a big fan of like, okay, great, I now have a solution that's purely reactive. I'd like to be more proactive than that. So I started to dig into this maintenance job and found that it didn't actually run the way that it was supposed to. And with the vendor that it configured it, the cron jobs didn't work correctly. They were not staggered. It it was just all or nothing. And to make it worse, it fired off a day late because of a weird little bug, and started right in time for the UK morning. Add to that it hadn't run ever successfully, and a couple months later, all of a sudden, it worked because somebody had made a change, and it pounded it on the Monday morning. So went in and took a look at it, and let me just pull this up. So this is the Tintri store. If you are being, if this is your first experience or first time seeing Tintri and or Veeam, I realize that John and Jamie really flew through their slides. So hopefully you'll get to see it, just in action. This is live. This is a live environment. This is my environment, and this is what it looks like down over here. There's 135 VMs in there, and so in the case of finding the latency, I've already pulled it up, and what had happened is after using the Tintri to discover how this thing works under the hood and what it's really doing and why this, on the application side, it was saying that nothing was running, but it was clear on the storage side that yes, something was running. So it was a great way to reconcile what I saw in Windows and the logs there and what was actually happening. And sometimes those things, go hand in hand, and sometimes they don't. Sometimes a job kicks off, and it's like, yep, successful, and it took 1 minute. 1 minute to send a command and 8 hours to execute it, or whatever the case may be. So when I started to dig into it, what I found was this is just looking at one of those indexes. So this is 02. And I found that right when it kicked in, it jumps up, and it does some writes initially, and then it spikes up here, and then comes up around 1,000 IOPS or so, and does a whole lot of reading. Now, when it first hits, this data has not been accessed, so it's sitting pretty cold. So this is almost 175 gigs or so of data that is now sitting somewhat cold in SATA. Now, the nice thing about the way that tiering works in the Tintri is that you don't need to choose what goes where. It's not all or none with your VMs. Whatever data is most popular will sit in your SSD. There's 2 terabytes of SSD fronting it, and then that 2 terabytes goes a lot further by deduping inside of it so that it acts like more than that. So if you've got a pile of servers all built from the same template, they basically take up the bits of one, and not even a whole VM, just the parts that actually get access. So the parts that on boot up of, say, Windows, those DLLs, and that would be actually referenced. Not all the junk that you never reference, media player and all that other stuff you don't want on a server, but comes anyway. So looking down at the IOPS, we see the spike. What happens is that when we look at our breakdown of latency here, I can see that we've got, it's broken into a stack. I got host latency, network latency, storage as a whole, and then the disk. And anytime you see disk, this is SATA. So if I were to look at the flash hit on it, yeah, okay, 100% flash hit because anything it needs is available in the SSD. And then it starts asking, and then the stuff that it asks for is not there, so it has to go to SATA. That in itself is not a big deal, but if it's got to go to SATA and displace data from that in a hurry, because this thing's just pounding away, that data then needs to go somewhere back into the SATA. No big deal when there's not a lot of movement in between. But in the case of 5 of these all hitting it at the same time, that was 900 gigs of data we want out, 900 gigs we want to push down, and brought the latency up over 200 milliseconds. Now, that was up there for maybe 10 minutes, and maybe around 30 minutes it may have tapered off and gone to normal, but, like quick, pull the plug. And again, I guess I didn't show you how we knew what it was. This is the whole data store. So point in time, if I wanted to know what just created this spike in latency, I click on that. Right point in time, you can see the mouse up. There's a total of, this is really, really high on the Tintri, 36 milliseconds. In our old environment, that was closer to normal. It certainly wasn't a spike, but it also wasn't, the best time of day. Best time of day would have been 15 to 20 milliseconds. And over on the right side, I can see the contributors that made that up. And there's that 1100 IOPS is coming from that index server. So that's how I knew to click into this, drill down, and pull it up here. Now, what's interesting about this is that when I see the IOPS, there was a latency spike here. Latency spike here, but and then down below it, there's a whole bunch of just IOPS in general. I can click again, point in time, figure out what's doing it, and there's 2 index servers. And if I click at this point in time, I now have 3 of them going. So what I found is if I staggered it in a way that pulled it out of the SATA into the SSD, it does it, it's then an SSD, and the rest of the job is SSD and has no latency for the rest of the system. So knowing that, I was like, okay, so I didn't need to let the whole job finish. I just needed to let it get into the SSD, kind of normalize, and then it continues on. The next little bump here is, see, this VM was barely even impacted when the next one started, and again when the next one started, and all the way through. It was barely impacted. So this was a way that I could look at what was happening, diagnose it, and then come up with a way to stagger these, know the timing, know that it's safe to run them at this time, and move on from there. Now it's I'm just talking into a phone here, so there's no feedback, so it is kind of strange, but hopefully it's going all right. Next one I've got for you is, and this is the last one, is about reducing backup size and time and knowing your data better. So how well do you know your data? In some cases, you may not know what's in a VM. You may not know how it's used. You may not even have access to what's inside of that VM to know how it's used to run your regular tools. So if you're in a multi-tenant environment or it's some sensitive data, it's locked down in a VM and you don't have access, that's fine. You can still do a lot of discovery. And I found that I can do discovery not only, the Tintri makes it great, but I can use my backups to discover things as well. So this picture is the snake, and that's because if I look at what jobs look like on disk, this is a list of, this is a single Veeam job, and this is sorted chronologically, and I'll show it in more detail. But over on the right, there's a size column, and the deltas aren't very big, and then there's some kind of bigger ones, and then some of them are really big. And all I'm really trying to show here is that it's sort of like the snake. So there's a big chunk of data in there. Maybe that's a VM that was added. Maybe that was a big chunk of that was copied at that point in time. And we can kind of get some time out from that, or maybe look at this and see that, hey, this is this looks like it's happening regularly at these times. And then inside the VM, we can look at the schedules and figure out what's actually creating that data. Now, in a Veeam job, this is not per VM, so this is of all the VMs in the job, which might be one, it might be dozens or even hundreds. So I found that between the Tintri and the VM, or in Veeam, I had information that wasn't, these are sort of some new tools I could use that told me more about my data, and but maybe weren't even the design of them in some cases. Like Veeam, I don't think designed it so that you could look at your backup sizes and figure out where it is, but it's certainly useful. So if we wanted to use that information, we can do that. So right on the dashboard, so this is a second Tintri that I put in January. So I was up at hit 97% capacity on the original one, and knew that I would be out by end of March. Proactively got another one in. Knew that I would be out because the nice metrics on the front, I get reports from it, and there's some trending, and I could see that it would fill up. So put the new one in, and left most of the workload on the other, just moved a couple of VMs just to create a little more capacity. So some arrays melt down when they get full or even close to full, or even over half in some cases. And this is sitting here at 880 gigs free. It's suggesting 74 days until it's full. Lots of performance reserves left. You can see that the latency is low on this. We're getting decent throughput. We got a range of IOPS. This is not the spikes. These are sort of averaged out inside of a 7-day period. And lots of insight there. We come over to our other array. I'm taking a look at it, and I'm looking over at the space changers on the right. So these are the top 10 changers. So this is sampled over a 7-day rolling period. And I can see which VMs are accounting for space. And this was one where I lost 155 gigs in this week. That is what happens when you delete a VM. This is one where it grew by 26 gigs. So I was digging in to try and find out, is this 26 gigs changed or net plus 26 gigs? And okay, why don't I find out? So this looks like a big straight line across here. This is specific to that one VM. And over at the bottom, a week ago, it was at 1,769 gigs. And today, it's at 1,796 gigs, which works out to about 27 gigs. And that accounts for it. And if I wanted to know where on this that was actually growing, not only can I see the VMs, so let me just hide this graph here. And get a complete list. And now here's this specific VM and all the actual VMDKs underneath of it. I can see, file size. Okay, that disk is, 360 gigs thereabouts. Here's all my size, and this is not how much has been provisioned. This is how much is actually in use. And there's more than just how much is in use. I can look at all the, there's a lot of information here. But what's pretty cool is this latency. I can see per disk latency. I can see per VM latency. I can see latency for the entire store. I can see if blocks were aligned because they were maybe a 2003 box. It was misaligned. And I can see our percentage of data change in here. And so this all of a sudden is accounting for. This is as a percentage. And if I were to look at that, use gig change, I can then track it down to, okay, so this VMDK added 4.6 gigs, this one's 2.9, right? And then I can find where the stuff's going. All of these are virtual disks. I can go into Windows and then look at where those disks are. And this is an example of where I can sort of understand my data a bit better. When I was talking about the snake, so let's just close this virtual lab. That virtual lab, I think we were showing it off over here. And this thing's going to clean itself up all nice and pretty for us when it's finished, and we don't have to do anything after. One's gone already, and the other ones go. Okay, and we'll let that clean up. We'll get back to our Veeam. We'll just take a real quick look at the disk. So here's a backup job. It's a series of VRB files. I won't get into the details on this. If you work with Veeam, you'd be very familiar with VRBs, VBKs, and VIBs. These are incrementals and rollbacks, and then the base file itself. And looking through this one here at 6 gigs is 40 times larger than the average. And I can also see that they are falling on a certain schedule. So using this information, I can just get more info about that. Once I know more about it, if this is temp data, and this happened to me where we were using SCOM, System Center Operation Manager, and it was doing some logging of the VMs and logging a whole pile of things into some pretty small files. This was 5 meg files, so 25 megabytes, but somehow accounted for over a gig an hour of data change. And that was just due to the way that it was unique data rolling forward across an NTFS volume. And I said, hey, that data changes a lot. I don't want to replicate that. I have limited WAN resources. I don't want to back it up because to me it's junk. It's great. It's super useful during operations, but that represents a lead ball and chain to me that I have to drag around in my backups and everywhere else. So what I ended up doing was, okay, using things that I found on information in the Tintri, looking into the graphs. I find, hey, every 5 minutes it's writing something. Dig in deeper, okay, track it back. Oh, it's this. So then I make another VMDK, and in that VMDK, this is the new home for that SCOM data. I exclude that from my replication. I exclude it from my backups, and now my backup sizes are smaller, and they don't take as long, and I don't have as much stuff to replicate. So that's just one example. Another might be user profile data. We have it set so they log into servers, and then it's deleted after them. You can put those off on another VMDK, exclude them completely, and not worry about that. And change block tracking is another piece that goes a long way. I was going to get into, but I'm getting a bit short on time, so I will just wrap it up right here. So this is, what we learned. Choose our tools wisely. So technology in this case was purchased for storage, and this was to hold data. And on the outset, I wouldn't have expected that this bucket for my data is going to be my new, not just hammer or screwdriver. It's my Swiss Army knife. It's doing all kinds of stuff for me, giving me insight that I didn't know about, that I then take and reiteratively apply to the VMs to make everything more predictable and smoother, and let the environment operate well so that I can achieve these high consolidation ratios without all the risks that are normally associated with it. Know your data from the inside out. You can learn a lot about what is happening just by looking at some charts. And so when things are dying down and it's not a fire that you're trying to put out, no active request, you can try and smooth these things out and make sure that this dashboard that I had showed here, you want to make sure that your VMs that are showing up as your top performance changers are the ones that should be there, because you invest in your storage and you don't want your junk VMs and your junk data to be eating up all your horsepower. So top one on the list, Exchange server. One right under it, our primary file server that holds all the profile data. Under that, Citrix servers, an index server. These are the top 10. These are all business critical. Our environment's 100% Citrix, so if there is a lot of latency, that is definitely going to kill us, and this keeps the latency really low. In that rare event that we actually see some, we have the tools to go in and do something about it. Think holistically. On the outset, I was going to replace some storage, and in a short amount of time, I knew that the lease would be done end of September, and if I was going to do anything, I had to make my move. So in about 9 months, from the beginning of last year through to September, I was able to free up all that hardware and replace the tin underneath everything we have with a much easier to run, simpler infrastructure, smarter storage, smarter backups, smarter tools. And with that, I will try and figure out how to pass this back over to Mark.
Thanks, Rob. That was fantastic. We really appreciate you going through all of the case studies. Very informative. And at this point, I'd like to open it up to our audience for Q&A. If you have questions for Rob or John or Jamie, please feel free to type them into the chat window. There have been several during the session. One I'd like to start out with, Rob, for you, is you obviously sound quite pleased with the technologies you were going through in the presentation, but what are some of the functionality differences in the products that were important to you or Maples when you were evaluating the tools for the environment?
I think ease of use was probably really high on the list. I didn't want to be getting out the crystal ball and figuring out, okay, which application is going to grow next year? Which is it? Do I have to give extra diff to this one, to that? I wanted it from a nice pool of resources, not just storage, but all of the compute from a nice dynamic pool that I can monitor at a top level, let the systems take what they need to take, reiteratively let tools evaluate it, and then tell me which ones are oversized, which are undersized, start to right-size everything, correct it, and then just, not worry about it. And then if something does happen, I want the ability to get into the infrastructure and in a short amount of time be able to pinpoint, what was the noisy neighbor, what was happening. And before, I just simply didn't have the tools to do it. The servers were spread out. I didn't have a single pane to look at. When I'm looking at vCenter now, it's I don't know if you noticed, it was all green down the side. It's pretty obvious when there's a red one, which one, has some problems. And before, there were just alarms all over the place, and it was difficult to, how to prioritize which to work on. So I think, my ease of use was probably a really big one.
Got it. Thanks, Rob. We have another question, and this is for you, Rob, as well. It says, if I'm using currently VMware SRM for recovery and Veeam for virtual backups, can Tintri simplify my DR scheme, or would I simply be recreating the wheel?
I'm not sure how much I can speak to this. So in some respects, you might be recreating the wheel, and in others not. So typically with SRM, you would have your array doing your replication for you. So in this case, you're letting Veeam do your replication for you. And I think that you can definitely leverage both. Maybe it is the backup that you want from Veeam, and since the replication is there, off you go. Maybe, Mark, you can speak to new Tintri features. I don't want to speak out of line on what's coming down the pipe.
No worries. I'll actually let John take the Tintri questions from an architecture and technology standpoint.
Yeah, sure. So if you're using SRM with Veeam today, introducing Tintri into your environment, it's just another data store. So actually, as we speak over the next couple of weeks, Tintri will be introducing our own replication. But again, as far as not wanting to change anything in your environment, leveraging the architecture you have today, if you just want to get all that VMware storage at the source or at the destination or even both sites, there's nothing to prevent you from doing that. So yes, by introducing Tintri in addition to your existing storage or instead of your existing storage, there's nothing to that would mandate change from that perspective.
Got it. Thanks, John. A question for you, Rob, and perhaps Jamie as well. Are you using Veeam 1 also along with Veeam Backup and Recovery?
I'm not. At the time when I was looking at management for it, I had evaluated a couple, and the one that I ended up going with was VCops, so VMware's product. So I use it for my dashboards and my oversight of what the environment looks like.
Got it. Okay. Rob, I've just given control back over to you.
Okay, great.
I believe you had asked for that.
Yeah, I just thought, while there's questions, instead of looking at a slide, put something better in front of the attendees. If they're anything like myself, then looking at data is better than a slide.
Sure. A question for you, Rob. When you create a virtual lab, do you need to include a domain controller?
Depends on your application. In my case, yes, I needed to include a domain controller. And that's been a sticky point for me because I've always been able to create virtual labs well before Veeam came out with virtual labs and before Veeam even existed, I think, if I go way back to when I first stumbled on link clones, probably in 2006 or so. And what I found was I would clone a domain controller, hey, fantastic, off I go. And sometimes it would work, and sometimes it wouldn't. And the reason for that is that it's sort of dependent on its own DNS, which is in there. It may or may not be a global catalog, and depending on the overall infrastructure, it might not actually be the sort of the active domain controller that it's looking for. So you'll notice this when you power the thing up, and it takes 15 minutes just before you can type anything in. Veeam has a script that runs inside that cleans it all up, does some kind of magic, and then I never have any of those problems with the domain controller. It's as it was, point in time. Put the VMs in. The only thing that that does happen is if you were taking a domain controller from a week ago and you're taking a VM from now or from yesterday, put them together, they may or may not work together. If they don't, it'll come up, say your trust relationships failed. All you got to do is log in local, pop it out of the domain, pop it back in, and that's because by default there's a 30-day rolling internal machine password on that. Once the DC likes it again, off you go.